Just so you all know that this session is being recorded. This meeting is being recorded to assist with record keeping and perhaps to be broadcast at a later date. If you are unhappy with this, please leave the meeting now. Very much. So thank you all. Diolch I ti gyd am bod yma heno. Dwi'n fynd I wneud yr introduction mewn Cymraeg I siaradwr Cymraeg heno. So dwi'n just fynd I rannu sgrin fi cyn I ni fynd I David. So dwi'n just fynd I siarad am dipyn bach amdan swydd fi. So gobeithio ti gyd yn gallu weld hwn. So dan I dwi ydy'r swyddog Awyr Dywyll am Parc Cenedlaethol Eryri. So be yw swyddog Awyr Dywyll? So mae pobl yn meddwl bod mae hwn yn rhywbeth I wneud efo gwaith fi. Mae pawb yn gofyn I fi os dwi'n gweithio am Darth Vader. Neu dwi'n wneud rhywbeth efo Star Wars. Ond mae swydd fi, oops, sorry, it's broken, there we go. Dwi'n gweithio mewn Skies Partnership, Project Norse, which just means the Night Project. And I work in a partnership, the Dark Skies Partnership. And I work for Snowdonia National Park, the Clwydian Range and Dee Valley, the Llyn Peninsula and Anglesey AUMB. So dwi'n gweithio rhwng yr ANE ac yr Parc Cenedlaethol. So dwi'n gweithio dros y Gogledd Cymru I gyd. So dwi efo ardal mawr iawn I gweithio drosodd, ond dwi'n lwcus iawn achos mae'n llefydd a ardal really hardd. So a bit more about the Dark Sky. So it's International Dark Sky Week. That's why we've got David here from Bug Life and other events going on this week. A Dark Sky Reserve is basically somewhere where we protect the darkness. So we do everything we can to minimise the light pollution in the boundary of the national park. Snowdonia has been a Dark Sky Reserve since 2016. It's the largest in Wales, and Wales is lucky enough to have 2 Dark Sky Reserves. And in fact, Wales has got the highest percentage of protected dark skies of anywhere in the world, which is really special. So I'm also working with the AUMBs, and we're working with those to get designations for those areas as well. So they will all hopefully by the end of this year have dark sky designations. So that's the Clwydian Range in Dee Valley in northeast, the island of Anglesey and the Llyn Peninsula as well. So we're doing lots of events all together, the AUMBs and the National Park, trying to promote dark skies and trying to educate people about light pollution. So a dark sky sounds a little bit silly because surely everywhere the nights are dark, the sky gets dark, but it's actually an area where the stars are visible to the naked eye with very little light pollution, and usually in a national park or an AUMB, which again doesn't sound like anything special, but 98% of the British population don't get to see a quality night sky, so they don't get to see hardly any stars at all, which is a massive number. And lucky for us in Wales, a big chunk of that 2% is the Welsh population. So part of my job is educating people to make them aware of the very special features that's on their doorstep and to protect that for future generations. So it seems like a big statistic, but this is a light pollution map. So this is Europe. And this is as far as I'm going to go before I hand over to David, but this is just so you can have some sort of idea of how bad light pollution is across Europe. So you can see, especially in Belgium and the Netherlands, where that red going to white light is, that's really bad light pollution. And as we move over to like the blues in the sea and the edges, that's where the pockets of darkness are. But what I find interesting from this map is you can see that we're not only affecting the land, we're also affecting the coastlines as well. So you can see all the shipping channels pretty much lit up. So we've got the English Channel down there, and the Dublin to Holyhead route is lit up as well. And these big splodges up there, they're actually oil rigs, which I was really surprised that they show up so brightly. And just before I hand over to David, this is just a closer picture of Wales. And as you can see, we're defined by our darkness. So we're actually really dark, and that's not a bad thing. That's a really good thing for a number of reasons. But you can see we have a lot of light polluting neighbours that I do try and influence in my work to try and reduce the light pollution there as well. But before I go any further and steal David's thunder, I'm going to introduce David, who has kindly decided to speak for us today or tonight, and he works for Bug Life. That's a really great organisation doing lots of education around insects. So David, I'll hand over to you.
Brilliant, thanks Danny. Right, I'll get my talk up on screen. There we are, hopefully everyone can see that. So yeah, my name's David. I work for Bug Life. Thank you very much for having me come here and talk to you today. My role is social change and advocacy officer. So I'm from the offset, I'm going to tell you I'm not an entomologist. I am very much here to help influence policy, help change people's perceptions, and really kind of deliver some of the kind of those bigger picture work that we do. I'm going to talk to you about the impact of artificial light on invertebrates, and some of the solutions that we might find with that, and things that can help. So, not moving on. Yeah. For those of you who don't know, Bug Life, we are the only organisation in Europe. We're concerned with the conservation of all invertebrates. So that isn't just insects, that's everything from jumping spiders to jellyfish, worms to woodlice, and everything in between. To say, the only one concerned with all of those, there's a number of other organisations who are concerned with specific species, but we deal with all of them. We work predominantly within the UK, but also in Europe and sometimes further afield as well. There is another kind of organisation similar to us in the United States, and together we all work really to achieve this aim of looking to halt invertebrate extinctions and achieve sustainable populations of invertebrates. It says in the UK, but obviously we're looking to achieve that across the world. We're supported by a number of member organisations who we work with to help support and achieve and develop our cause. So you might be asking why invertebrates, why they're important. Well, invertebrates make up 65%, roughly, there or thereabouts, of terrestrial and freshwater biodiversity. So almost 2/3 of all biodiversity is actually invertebrates. And we consider these to be the life that supports the bottom of the pyramid. So everything above it, all of the vertebrates, all of the kind of the key focus on birds and mammals and etc., supported by insects and invertebrates, and the range of kind of services that they provide are there on the screen. You'll be familiar with things such as pollination. Obviously, the focus on things like bees in particular is quite well known, but invertebrates really deliver a lot more things such as pest and weed control, soil production. They actually degrade organic matter and help us develop our soils from which obviously we can grow food. They help filter clean water. And also they deliver things like nutrient recycling. They also are a food source for other animals, obviously, but also in some cases for humans as well. And one of the things with invertebrates is there's a huge bias towards everything else, so towards your vertebrates. And this is the case for conservation, but also for research. So we really see our role as speaking up for the little guys that help to run the planet and make sure that the pyramid doesn't topple. So you may have seen that a number of stories over the recent years that are quite well publicly known around the potential risks to invertebrates. Studies estimate that up to 41% of insect species could actually be lost over the next few decades, which, when you think about it, is huge amounts. Nearly half of all insects are actually threatened from extinction. Our No Insect Extinction Manifesto sets out what we believe we need to do to address this, to help reverse decline, or firstly halt declines and then reverse declines in this crisis. there are a large number of factors that are actually impacting invertebrates, if you can imagine. Obviously, there's the smallest, tiniest little animals, and obviously there's a lot of things that need to come into play to make sure that they can thrive. But the key drivers really are habitat loss and degradation, climate change, pollution, and chemical use. Excuse me. So our manifesto sets out 3 key areas of work to help reverse these declines. Firstly, being room for insects to thrive, so creating and reconnecting the wild spaces which insects live. Then making sure those spaces are safe for insects to actually live, which really involves freeing up the land and the water from things such as pollution and invasive species. So once we've actually made these spaces, making sure that these spaces last and insects can thrive. And then finally, improving our relationships with insects and helping to even out that bias that I was referring to. Now, with light pollution, obviously that comes into a couple of these, in particular, the safe spaces for insects, as well as helping to improve the friendlier relationships with insects. And I get to talk about 2/3 of the insect population. So hopefully we can infuse you to get excited about some of our nocturnal species that you might otherwise not know about. So what's the problem with light pollution, and why am I here to talk about these things with you? Well, for all of those insects that we have, 64% of them roughly live wholly or partially at night. So it means that there's a vast number of all of these insect species that are nocturnal, that don't come out during the daytime, and anything that directly impacts the nighttime has the potential to impact these species. So we really need to take this seriously and address these issues as we would any daytime related issues. Just because it gets dark and we can't see necessarily what's going on doesn't mean that things aren't being impacted. We're also seeing more and more emerging research about the impacts of light pollution on daytime insects as well. So no longer is this just restricted to the dark hours, it's actually having a knock-on effect. So again, it's starting to really gear up the need to address this. We know that light pollution, as Danny said, is impacting a huge amount of the planet, not just in the UK, but further afield. And that's having an impact not just on insects, not just on humans, on our ability to see the night sky, but also on bats, birds, plants, and mammals. So there's a big area to address here with light pollution, and the research is always emerging. I referred to that bias previously around the vertebrates against invertebrates, and actually there's a significant bias towards diurnal, so the day flying or the day active insects rather than the nighttime. So there's a bias within a bias that's actually impacting the nighttime species. The image that you see on the screen here, this is actually a moth sheet, and it just shows and demonstrates quite nicely the impact that just a single light can have on essentially nocturnal species. There's a wide mix, mostly moths in there, but there's also beetles and flies. I should say this is actually an image from the United States, but it zoomed out, it meant you could make out some of the larger moth species that we don't have over here. But it demonstrates really well that actually just a single light can attract a lot of insects towards it, and I'll come on to why that happens to be and some of the problems that faces. But first, I just wanted to mention about moth traps. It's a way that we actually monitor nocturnal species. Just simply because of this attraction to light, it's a good way of being able to get these species that we wouldn't otherwise see into a place that we can study them, understand their populations. Now you might go, oh, that's a bit of a contradiction when we're looking to address light pollution, but obviously there is a need to balance out the monitoring side of things as well. And one of the things with monitoring like this is that light won't stay on forever. That light will get turned off once the study's been done. It will get taken down and it will be moved as well. So it's not quite the same thing, but I just wanted to talk about that at that stage. So why are insects attracted to light? Which is a question, unfortunately, I'm not going to be able to answer for you today, believe it or not. So sorry to anyone who was coming here hoping for that answer. It's a phenomenon that has been understood for a very long time. You'll all be familiar with the phrase "like a moth to a flame," which has been in regular use since the 17th century, and there's evidence of it being used prior to that. But the actual reason why insects are attracted to these lights, it's a little bit inconclusive. There's a number of theories out there as to this attraction to light, which is known as positive phototaxis, but it really remains a mystery. There's a wide range of theories, a lot of which are linked towards things such as navigation, but there's no agreed reason. So what's really more important is to talk about the impacts that we know that light is causing and how we can address those, rather than trying to focus on what it is that actually is driving insects towards things. Now, here we've got a picture of an elephant hawkmoth. This is a UK species. It should start to come out kind of from next month onwards. There's a few early reports, but it needs it to be a little bit warmer than we're currently seeing. Well worth looking out for. Those colours are real. It's quite a large moth, and so yeah, it feeds off the willow herb, which is its food plant. So if anyone's got any willow herb close by, look out for the elephant hawkmoth. It's a spectacular species. What I really wanted to demonstrate with this photo and talk about here is its eye. If you see, it's a huge eye. Operates in a very, very different way to humans and the way we see things. Insects view things in a very different wavelength, and actually have a completely different understanding of the nighttime than we do. We know that many insects favor the lights, the UV lights, and the lights that are at the green-blue end of the spectrum, and we think that this is really down to quite a long period of evolution where the particular plants that the insects would feed off at night are able to kind of be more present and more attractive in those wavelengths. So your blue plants and your darker plants that you don't necessarily see in the daytime as much flowering, but in the nighttime they are, and these are attracting the insects towards them. So it's basically something to be aware of, that just because we see light lighting up our darkness in one way, insects see the nighttime in a completely different way to us. So we might not understand exactly why insects are drawn to a light, but we are starting to understand a lot more what impacts that is having on the insects. Some shocking statistics as well are coming out as a result of these emerging studies. One study in Germany has identified up to a third of insects that are attracted to a street light will die as a consequence of that. And straight away that would signal alarm bells and signal that we really need to be considering these things. If a third of all any species is being attracted to something and dying as a result of it, then surely that's not right, and we need to suss that out. The reason that they're dying is through things such as increased predation from bats and birds, who are starting to learn that they can sit quite close to nighttime lights and essentially pick off all of the insects that are attracted towards it. You'll also see other insects, things like wasps and spiders, for example, setting up close to lights because they know insects are going to be drawn to the lights and become easy pickings. But also the other thing, and it's demonstrated really nicely in this image here, is that insects can just become completely exhausted and die as a result of exhaustion. The image here, it shows basically the flight paths of individual insects. You can see a lot of swirling and a lot of attention right up close to the light, but very rarely do they actually merge off into the darkness, and they just become stuck in that kind of light sphere. And again, going back to why, some of the reasons why these insects might be attracted to light, there's a lot of thinking that it is around navigation, and insects trying to keep the moonlight that they would normally navigate by on one particular side, and a light, obviously, it's fixed, it's very bright, and they're trying to get out of the light whilst also still understanding where the light is, and that's where you see these swirling patterns. Insects also have then this inability to move away from the light, this kind of obsession. So, you know, it's really attractive. If you can imagine the insects being attracted to those particular wavelengths of light, you know, as if it would be going to find a particular flower, then the light acts as this beacon. And you will see this through things you may have seen or heard cockchafer beetles in the UK hitting your glass windows at night, where light's actually escaping outside, and the beetle's coming in and trying to hit the light, and it sounds like a tapping on the window. And actually that's this positive phototaxis, where the insects are trying to stick with the light and coming up to light. Or you may well have seen or be familiar with the kind of bug zappers, the sort of the blue lights, the high voltage that insects get attracted to, particularly in porch areas and in industrial kitchens, which actually kill the insects. They're attracted to it and they can't stop it. They're drawn to it. And obviously this is a key problem, because we can't teach the insects otherwise, but what we can do is address the light source, and that's really where we need to focus. It's not just this physical attraction to light that is really causing problems for insect populations. This is a really recent study by Boys et al., which looked at the full life cycle of moths in particular. And there's a bias within a bias within a bias. And there's a lot of attention on moths. That's because there's a huge range of moths. They're quite interesting to study and understand. And it's where most of the research within light pollution has been carried out. And what we see here in this diagram, which is quite extensive, is anything in the kind of the dark grey boxes is understood. This is known to science. There is research to back this up and show that these are impacts caused directly by light pollution. The areas then in lighter grey are areas where we're starting to get an understanding, but it's not kind of unequivocal evidence yet. And then the sort of the broken lines are areas where we expect there to be problem with light pollution. So you can see that obviously there's elements of navigation which are having problems, but also things such as reproduction, actually impacting the pheromone production, which moths will put out to attract their mates. Also with regards to the amount of sperm that's released and actually the ability to mate. Then there's also problems that are being seen in the development of the larvae and the pupa being mistimed in its emergence. If you can imagine that light pollution is impacting day-night cycles, animals or insects that emerge at night, in the daytime, are starting to emerge at night because they believe it to be daytime. Such an impact light can have on them. And then obviously it's causing things such as the predation that we've talked about a little bit already, but also it does impact plants and food plants' ability to actually go about its life cycle. And there's a growing evidence around the impact of lights on plants. Obviously, we use lights to help plants grow, but also that's having an impact on plants' ability to rest and go through its nocturnal phases as well. So there's a whole range of impacts that are not just physically based around its flight and the attraction to light, but that it's being caused by light pollution. And one of the things that we don't have unequivocally at this stage is its impact on long-term population trends, because there hasn't been the studies yet. We just haven't had it there. But when you start to add up all of these immediate impacts that there is evidence for, it means something needs to be done now. We shouldn't wait until we completely see populations be depleted. We can actually start to address this now and get it before we don't know those longer term impacts that it might have. As I mentioned, there's that bias towards moths in the insect world at night, but it's also important to recognize that there are vast numbers of impacts that are being identified to other invertebrates. Danny mentioned the oil rigs out in the North Sea. Well, there's evidence of crabs and other invertebrates being attracted towards lights. And you'll see this in port areas as well, where species are being drawn towards these lit up areas. There's something going on which isn't natural. It's a change in that natural cycle that needs to be addressed. here I've got some images of mayflies. Now, mayflies are a really interesting species. They spend most of their lifetime underwater, only emerging as adults very briefly to go and reproduce, so much so that's their only purpose. They don't have mouth parts to go off and feed. They go to reproduce. When they leave the water, they go to find a mate, and then they are attracted to light as a reflection to understand where the water is. And what we're starting to see in a number of places is these flies flying up and then mistaking roads, particularly bridges or roads that run parallel to rivers, for water surfaces. And what will happen in order to get out of the way and lay the eggs as quickly as possible is these insects will fly down and lay the eggs on that immediate point. Now, obviously, when that's water, that's great. That's where they want to be. However, in these reflected surfaces from light, it will mean that insects are laying their eggs where they shouldn't be, and it's an inability then to continue that cycle of growth. As I say, this is having such a significant issue in certain areas that there's even a term coined for this, and it's summer snow. And in some places and in some bridges, we're finding mayflies that are a couple of centimeters deep, dead on the roads. And if you consider that can be an entire population that's gone to breed on that that particular day that they've taken flight, that just haven't actually delivered their eggs to the water. The consequence for that long term could be huge and significant. So we need to make sure that we're not just considering the impacts of moths and kind of the sort of the more traditional terrestrial species, but also some of the water-based species as well. Now here we have a glowworm, which I'm sure you're familiar with, but there's a good chance that not many people have had the ability to see them. They're kind of well known to be in decline. And a lot of the studies around light pollution in glowworms are starting to identify a change in behavior of the worms itself. They emit this light to attract prey, to also attract partners to mate. And what we're starting to find is areas of glowworms habitat where lights are present, so where there is light pollution casting over it. These worms are just stopping signaling. They're not lighting, so they're not going about their daily activity as normal. And obviously that's then having a knock-on impact on the ability to mate and the ability for them to feed. And it's just something that really shouldn't be happening. The poor old glowworm is also not really showing the ability to adapt, to move away from its habitat, such as the fragmentation of the habitat. And they're staying there and living out their lives without actually carrying out their livelihood, so to speak. And down there is the snail. And as I said, we cover all invertebrates. Snails and slugs are also shown to be attracted to light. Gardeners take note, if there's a light source, the snails and slugs will actually come towards it. Now, that's having a really interesting impact because the species that feed off of slugs and snails, instantly a glowworm being one of them, are actually avoiding the light or unable to activate or be active in the light. So if you think of species such as hedgehogs, for example, they're the opposite. They actively avoid light. And there is a theory that slugs and snails are coming towards light sources because they'll actually survive and avoid predation. So it's really interesting to see these knock-on impacts that are not just having on the species itself, but on the wider species. So gardeners, that's one to consider when I come on to some of the actions that we can take regarding light pollution. That actually, if you're lighting up your garden, you perhaps drawing in the slugs and snails towards the areas where actually you're trying to avoid them. And you'll also see this quite commonly on windows. Sometimes, if you happen to look out your window at night, you'll see a snail crawling up along the window pane as well. And again, it's that similar process of attraction to light. So luckily, I've used a slightly different map to Danny used here to demonstrate light pollution in Northwest Europe. and yeah, there it similarly picks up some of those North Sea oil rig platforms as well. And it really identifies the coastal outline, as Danny was talking about there. You can almost make out the entirety of the UK there through light pollution. Thankfully, this map also shows some dark areas as well, like the North Wales, Mid Wales. So you're quite lucky where you are in that it's still quite dark. Down in the southwest, down in Devon, where we have a few kind of significant patches of light pollution, but also a few dark areas. But when you start looking at the large urban areas there, you can really see the impact that light is having on the nighttime. Really, we want really that to be just quite dark and quite dim, because this is the view from space. This is what's going up and out. But what this really demonstrates is that light pollution isn't just a problem we can solve as individuals. It's a landscape scale problem, and it's combined with other issues such as the habitat fragmentation I'm talking about with the glowworms there, that needs to be addressed not just by conservation organizations, not just by businesses, not just by policymakers, but by everyone, to start to act to help reduce light pollution. And I'm really optimistic about this. Only today, it's very, very recent news, as in within the last day, CPRE have released results of their annual star count, which has shown that actually light pollution during lockdown has reduced somewhat, with more people being able to see the night sky, which is brilliant. And it just shows that actually some changes can actually lead to a positive outcome. And we are very much advocating for the right light in the right place at the right time. And I'll come on to what I mean by that in a moment. But one of the things that light pollution offers is it's a fairly simple solution to a pollution problem where other pollution or other forms of pollution might not be so easy to solve, in that actually once the light is gone and once you've turned the light out, it doesn't linger around. So it seems very simple. Let's turn off all the lights. However, we know that's not possible. We know that there's a balance that needs to be struck here in order to really address this properly and correctly. Obviously, we have things such as our nighttime activities, our nighttime recreation, things like sporting things, particularly in the winter months where it's darker and you want to be able to go out and do your things in the evening time. You need to light those things up in order to see. And obviously, there's things such as safety along roads and obviously public safety when out and about walking. However, I think a balance can be struck here, and we're starting to look at ways that we can do that, and ways that we can achieve that, and again, how we can all work together to address this nocturnal landscape scale problem and essentially rewild our nights. And I know that's a phrase that's used quite commonly within the conservation sector at the moment, but really it focuses quite heavily on the daytime conservation issues rather than the nighttime conservation issues. So what actions can we be taking on light pollution, and what can we do? And personally, first and foremost, we can all take action on light pollution. We can all reduce our personal consumption of light. I think we're probably all failing to acknowledge all of our lights all the time correctly. And we'll probably all be able to go and identify unnecessary lights that we leave on, either deliberately to light something up that we perhaps want to see, or just, undeliberately, you might forget to turn a light off. For example, you might forget to even shut your curtains. Sometimes people like to see out and it just continues to shine light out of the house. We can also do this by simply reducing the length of time that lights are actually left on. If we start to cut down the length of time that lights are on, we can start to reduce the actual amount of light pollution that we're facing. And we can do this using things such as motion sensors or timers, for example. Stop lighting the wrong place is a no-brainer, really. In particular areas like trees and hedgerows, we're lighting them up maybe to make them, to look beautiful and interesting, but it's having a huge impact on the species that are actually living in those areas. So making sure that we're not lighting the wrong places is going to be key. You can do this either by turning off the lights that are lighting up those places, or through fitting shields onto your lights or angling lights downwards. The correct installation of lights can actually have a huge impact on making sure that lights doesn't spread to unnecessary areas. So supporting organisations that are working on light pollution. It's not just Bug Life. I mentioned CPRE, who do a yearly star count. The International Dark Skies Association. Obviously, you're all aware and familiar with the work that they're doing. As well as the Commission for Dark Skies, Bat Conservation Trust, and other organisations who are looking to do this. As I said, this is a really emerging area for research and conservation, and the more we know and the more we understand, and the more action we all take together, the better we can address these issues. And of course, encouraging others, sharing the message. It's a really misunderstood and, hopefully I've been able to, if you pardon pun, shed some light on some of the issues of light pollution today. And we need to do that to our friends, our neighbours, as well as to our elected officials as well. It's really important. As an organisation, we're working on increasing that awareness. I'm here, speaking to you today and speaking to others about this, trying to raise that issue, not just to the general public, but through education systems as well, to policymakers and to lighting professionals, so we can all start to work together to address this issue. And as I say, it's an issue of pollution that actually we can address, we can do something about and start to tackle much quicker, much more readily than some of the other issues. And given all of the impacts that light pollution is having, not just on insects, but on other species as well, it makes sense to start to address these if we can. Why try to go for something that's really, really big and nigh on impossible to try and address when we're missing out these things that we can address quite quickly and quite readily? And then we can keep building onto those other things as well, and we can take people on the journey. And that's one of the nice things about those personal impacts. You can actually do something. You can go out tonight and make sure that your exterior light isn't left on all night, and actually you might be saving a third of insects' lives that would be coming in and attracted to that. And it's an interesting thing to do, actually, if you go and look at your outside light and see how many insects are around there. Obviously, we're in the winter months, so there's not so much active, but I almost guarantee that there will be some sort of invertebrate in or around your outside light at the moment. And then obviously we are working on kind of how we can change the policy and address this. We are calling for a national target on light pollution to include no net increase, and also to increase then the number of dark sky reserves. Obviously a lot of work's going on already in a lot of the protected landscapes, such as the national parks and the areas of outstanding natural beauty, to become dark sky reserves, which are really great ways of getting people involved, getting people to understand these ideas and starting to address them. And with regard to a national target, those light pollution maps are now becoming regularly updated. We're actually able to measure the light pollution that we have in our skies, and that's crucial. If we start to see an increase in light pollution, we're getting things very, very wrong. So we can actually start to go, right, well, we can start to reduce this, and hopefully those maps that we see will start to see dimming down so that there's less light pollution going out into the skies. And there are a number of ways in which we can do this that are already built into the kind of our political systems, particularly around things such as the Environment Bill, which is looking to set biodiversity targets, which we want to make sure that there's some sort of target considering the nocturnal species, but also things through planning as well, and the way that new builds are being, new houses and new developments are being built, to start to consider the impacts that light pollution and lighting is having. And the same can be said for things such as recreational facilities as well. Rather than just making sure that we are completely lighting up the areas that we see, making sure that we're lighting up the areas that we don't need to see. Everyone will be familiar with kind of things such as multi-use sports facilities that are lit up and provide a glow on the night sky, and things like sports stadium as well. If we can start to work with those big areas that are causing light pollution, we can really start to reverse these declines in insect species that are being impacted by light pollution. That brings me to the end of the talk with sort of the opportunity then for everyone to ask questions, and hopefully we can have a bit of discussion around any of the things that I've discussed today, and yeah, we can see where it goes.
Thank you very much, David. That was really, really interesting. And I love insects, so it's good for me as well. Has anyone got any questions? You can either type in the chat, and if you're a Welsh speaker, you're welcome to ask a question in Welsh on the chat or over your microphone, and Delyth will translate. Remember, I can't see all of you, so you can also raise your hand on Zoom as well. So if anyone has any questions, now is the time.
Hi, what kind of metrics do you use when you're kind of measuring light pollution?
So, Danny, do you want to say that?
No, that's okay. When I do the measurements, I use an SQM reader, so a sky quality meter reader. They're from a company called Unihedron, and they use magnet arcs per second, which is a really weird measurement. But it basically tells me how much light pollution is in the night sky. There are other ways to measure it. I'm not a lighting specialist, so I just use the equipment and take the readings. I don't understand any more of it. Like there's nano optics and things like that people use. Do you do any light measurements, David, in your line of work?
No, we don't. So we borrow from other organisations on that side. I'm not entirely sure. I think your answer, Danny, is more than I could have given on that one.
Yeah, so part of when you have a reserve or when you have a dark sky designation from the International Dark Sky Association, you do have to keep up a programme of monitoring. So we've been monitoring the light pollution in the national park for the last 6 to 7 years. It's been a bit tricky last year because of COVID and the restrictions. But the other areas now, we've got a good set of data for them now, between 3 and 4 years, depending on which AUMB you go to. So we're able to see where there's hot spots for light or where it's getting better. And I'm glad to say that in a lot of our areas, we are actually getting darker, which is good. We have got a question here, David, saying, are there types of light, e.g. red, which are less harmful, from Bethan?
Yep, so that's a really good question. And the answer to that is possibly, but also possibly not. More and more research is coming out. There was an understanding that the end of the spectrum, in sort of the green and the blue light, was actually causing more problems. However, that has been shown to be the opposite in some other species as well. So there's not going to be one particular wavelength that is good for everything. So I don't want to say that, you know, we just use the sort of the lighting that's at the warmer end of the spectrum and we're going to protect all insects and all species. However, it does seem to be that the vast majority of lighting that is at that sort of warmer end of the spectrum and the red end of the spectrum is better, but there are impacts that can be being felt. So what we are really keen on is focusing on the amount of light and the actual brightness of light that's being used and the length of time that it's being used as well, to kind of address that, because we don't want to go down that kind of route of going, this is going to solve everything, only to find out that actually in a number of years' time, when people have started to study certain other species, it's going to have an impact. So it's a tricky one, and as I say, it's really because there's so much kind of or there's not enough, I suppose, research into that yet.
And just to add to that, what we ask for in the national park is that we do ask for a warmer light, because it's got less of that blue content or the green content. And we ask for 2700 as a best practice, both for biodiversity. Obviously, it still does have an impact. It's going to always have an impact because you're putting light somewhere where it isn't going to. So always the best case is that when you're not using the light is to switch it off, as David has said, or to have a motion sensor. We make sure all lights in the parks are fully shielded and facing downwards. That's especially important on where habitat is, or like on the edge of trees, forest and hedges. We make sure that there's no light spill going backwards into the hedges and trees. That's to make flight pathways for insects, for bats, for birds, things like that, so they're not disturbed. We make like these little darkness corridors, which is something that's becoming a bit more used across Wales. I know Pembrokeshire National Park, they're talking about bat corridors, and they have bee corridors as well, which they are using different types of light for. And it also can come down to the height of the lamp as well. So we try and keep stuff as low to the ground as possible, so that it's not going to interfere with anything flying overhead. But it's impossible to remove all of it from having any impact at all unless you turn the light off. There is research being done, but it's being done by manufacturers of light, so you've always got to take that with a pinch of salt as to whether you know, I've had one manufacturer come to me and they've said that 1700 Kelvin, which is the temperature of the light, that's their cures all. But that's one manufacturer, and you know, that could be lucrative for them, so I have to take everything with a pinch of salt. But yeah, the best thing you can do is just to turn your lights off if it's not being used. We have got another question. Does the dark skies designation give any protection under planning policies? I think that one's for me rather than David. But yes, the dark sky designations, as part of the designation, when they're adopted, you have to have planning guidance be adopted by the county or by the national park, the authority. That's the only way you can get your designation. So that's the stage we are at with the Clwydian Range and Dee Valley AUMB at the moment. So it's with their planning departments at the moment. Once those are formally adopted, there will be planning policies in place, so that any new build or anyone who wants to put out a new lighting scheme, it will have to go to planning. And we will have to okay it. That's also what happens in the national park. So I do get to look at loads of planning applications and decide whether they are suitable or not, and I can make recommendations, or I can simply say that light is not appropriate in that setting. And you know, we're lucky to live and work in these special places, and they are so special that if people want to live in them, they've got to respect that it's a special living landscape as well, or a living nightscape. And a lot of people do understand, and a lot of people do want to do the right thing. We have got some new questions. One for you, David, I think. On what scale does this impact the addition of an illuminated signpost in a city, for example? Would this have a cumulative effect? So I guess we're talking about billboards and things in cities.
Yeah, so there's really interesting things with regards to, you know, from what distance an insect might travel towards the light, and there's some interesting studies about this impact, whether it acts as a bit of a sink and it draws everything in, and how far away, you know, the light would be. What's interesting is the studies show that if you light up a darker area, the insects will travel from further towards the light, whereas if you put a moth trap, for example, in an already quite light area, you'll get less distance from those insects traveling towards that. So in a city, it's, you know, it's yes, it's going to have you know, it's going to have a cumulative impact. All of the light pollution has a cumulative impact. The more lights that are on, the more pollution that's reflecting up and out. In terms of for the insects itself, it's kind of really tricky to say. If you can imagine, it's quite hard to source an insect to then identify how far it's traveling, for example. They are starting to find things like roadways, and the light can almost act as a barrier. So insects that would normally travel across a surface that isn't lit might get, or across kind of a highway that isn't lit. Once the lights go on, they stop at that thing, you know, so they can't carry on along their corridors. So anything that's moving around overhead might get, you know, it might act as a barrier for that kind of natural travel. So there's a number of different effects, but obviously all added together, it is going to have quite you know, it's all going to add together to have that cumulative impact.
I think it's important as well that we are talking about, obviously I work for the national parks and the AUMBs and their rural areas, but it's just as important for urban areas to get their lighting right, and if not so, more important, because light doesn't just affect our insects and our invertebrates, it actually affects human health as well. So when we look at lighting, we are doing it for our residents' health, and you know, the more urban, the more urban an area you live, the more of a negative impact that light pollution is going to have on your local biodiversity and on your own health as well. Because I think we get very used to looking at ecosystems as something separate from us and something away from us. But as David was saying, you know, we're coming towards an insect apocalypse. We're wiping out huge amounts of the ecosystem, and that is going to impact on us at some point, whether we like it or not. We can't control it. So unless we put things in place to protect our insects, you know, it's going to have a devastating impact on our health in one way or another. But more instantly, it can have very detrimental effects on human health in terms of insomnia, depression, and even disrupting hormonal patterns, because we are animals at the end of the day, and we too evolved to respond to light cues, and we've completely disrupted those in ourselves as well. We have some more questions from Meriel. Really interesting. Before this talk, I had no idea of the impact of light pollution on invertebrates. A large developer has applied for planning close to our fields managed for wildlife. The developer has been advised that security cameras need to be on all night. I'm concerned about the impact. Is there an impact around a quarter of a mile away from the light source? So I think that's similar to what you were saying earlier, David. And I've had this issue myself with CCTV, whereas people use really cheap CCTV because they want to save costs. So they have to have the light on all night because the CCTV that is cheap can't respond very well to light changes when a motion sensor light comes on. But in that case, I would personally tell them to spend more money on CCTV that will respond well to motion sensor lighting. But David, have you got anything you want to add to that one?
I think, yeah, as I say, I think covered a little bit by the previous one. And yeah, I would say the exact same thing, that, you know, the lighting, there's a lot of talk about lighting and security, but actually if you're looking at the CCTV element, what light does create is it also creates darkness. So it creates kind of the shadows either side of the light, really. So from that particular security element, better CCTV that can activate at night without the need for those lights is going to be the best way there. And again, coming back down then to, it depends on where it's located with regards to what impact it will have on the invertebrate, but those immediate invertebrates that will be around there will obviously have an impact as a result of that.
I've got a message here from Kate. I don't know if we're going to have an answer for this one because it's quite specific, but it is interesting. Curious if some nocturnal insects have effectively been extirpated from locations with high light pollution over many years. Has there been a need to reintroduce nocturnal insects from dark sky areas after mitigating light pollution in an area like this?
Really interesting question, and I don't think, as far as I'm aware, that there hasn't been, certainly not in the UK, and it's certainly not come across my radar. If it has, again, I think a lot of it is to go back to that lack of understanding in this area of work. And if you consider really quite a lot, and there's been quite a big talk around reintroductions of species, not just invertebrates, but other species kind of more recently. Again, the nocturnal areas is going to be less considered, perhaps. I'm not sure, there might have been something done around things like glowworms, but I don't know any kind of big scale examples at the moment.
I've just had one that's come to mind, and because you said glowworms, there's a place in North Wales called the Great Orme in Llandudno, which has got a famous glowworm colony. And in 2014, I think it was, there was an article written in the Nature journal, and a woman who was a glowworm specialist was on her holidays to see the glowworms, and they just changed the street lighting around the area. There's a road that goes along the bottom of the Great Orme. It's basically like I don't know, like a cliff that goes out into the sea that you can drive along. And she found piles of dead male glowworms at the bottom of these streetlights, and they'd almost wiped out their entire glowworm colony in the space of 2 weeks. So they haven't re-released or reintroduced nocturnal insects there, but they have had to change the lights completely. And now that glowworm colony is having to build itself back up slowly. But it's interesting with glowworms because I've only ever seen two in the wild myself. I've never seen them in big numbers or anything. So I think they are definitely in decline. One for you is, does Bug Life have any publications that can be used for dark skies campaigns?
Sure. So yes, and yes, more to come. So we did a study, or kind of released a report in 2011, the impacts of artificial light on invertebrates, that kind of reviewed a lot of the literature existing up until that point, and kind of came up with a lot of suggestions and recommendations which still fit true today. So it's still quite a useful thing. However, there is quite a lot more research that's come out since then. Part of my area of work is looking to develop this social change aspect, so I will be, so kind of watch the space into the summer months, producing some things that the public can use to get a bit more involved, and I can consider how we can fit some of those studies into things that can be used as evidence for dark skies campaigns as well. So yeah, that should be, I'll make sure that's part of my my work stream.
We got a question from Chad here as well, saying any research regarding the difference of light pollution during a full moon and new moon. So I think Chad means probably the impact of light pollution during a full moon and a new moon. And I guess that's going into like lunar cycles of insects and wildlife. I know it affects certain types of birds and certain types of mammals, but I'm not entirely sure about moths and other invertebrates. But I don't know if you've got, because I think we talked about this a little bit at the beginning, didn't we? About the if we had actual evidence of it. Yeah,
so this is one of the areas where it's really challenging, because we don't necessarily have the evidence to be able to compare it to, simply because the lights are on and the light pollution is already there. So if you can imagine, we would have to turn off all the lights and go through a whole number of cycles without the lights to see the impact. I believe that there is an understanding of how moths in particular use the moon to navigate, and there seems to be less attraction to light, in particular moth traps. So moth traps during, if you speak to moth trappers, they'll probably prefer a new moon in order to actually go out and do their moth trapping, because they'll attract more species to their light trap. Simply, I guess there's less competitive light out there. But I don't necessarily know that it's hard evidence at this stage in time.
Yeah, I think a moth trapper did say, Kelly, moths seem to be less attracted to moth traps when a full moon, so Kelly clearly likes a moth trap. But is there any other questions? I'm just sending a message. But everyone is saying thank you so far, David, for that very good talk.
Well, thank you for sticking by and listening for it. If anyone does have any questions after this, then feel free to contact us via my email there, or get in touch via the Bug Life website as well. It's pretty easy to find.
Everyone has my email because you all booked through me. And I'm really impressed at how many people have come from all over. We were truly international tonight. So thank you everyone who has come from all over the world. It's been quite impressive. If you do want anything from David, you can email me. You've got my email. It is International Dark Sky Week. So if you visit the International Dark Sky Association's website, they've got literally hundreds of events going on this week in all the different time zones. So many topics that are being covered. I've got events on for the rest of this week. So on Thursday, this one's quite specific, but it's Bats of Snowdonia. Is one talk. I've got Chasing the Northern Lights with Dr. Rosie Johnson, who is what they call an Aurorasaurus, somebody who chases the aurora and studies the aurora, which is going to be very interesting. She's a scientist who studies like the solar flares and things like that. On Friday, I have a talk with Professor Clive Ruggles, who is an astroarchaeologist, and he looks at the links between the night sky and the constellations, and why we have built things like burial mounds and the connection with our ancestors in the night sky, which is going to be really interesting. And then on Saturday, I've got a talk on meteors and meteorites and how to find them with Roy Alexander, who's a member of the Royal Astronomical Society. You can follow us, Project Norse, which just means the Night Project, on Facebook and social media. I've got loads of information on how you can support our Dark Skies efforts in Wales, but there are also tips you can take to wherever you are in the world to make your little corner a bit darker. And yeah, just thank you everyone very much for coming. I hope you've all enjoyed. Diolch yn fawr pawb, and I am happy to let you all go and live your lives. Thank you, David.
Cheers, thanks everyone.